Today we're going to talk about scale drawings and models. So a scale drawing is a proportional two-dimensional drawing of an object. So here we have a scale drawing of a first floor plan. And this is typical if you are building a house or a school or any type of building. You're going to have a scale drawing of what the rooms and the layout is. A scale model is a proportional three-dimensional model of an object. And so this is actually an apartment complex in Reston, and it is a model, so everything is in proportion, but it's on a much smaller scale. Measurements in scale drawings and models are proportional to the measurements of the actual object. The scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. So you're comparing the measurements of the drawing or model with the actual measurements. So here we have a proportion that 1 inch is equivalent to 10 miles. You can also write this like this, 1 inch over 10 miles. So let's look at an example. The liquid outer core of Earth is 2,300 kilometers thick. The scale model of the layers of Earth has a scale of 1 inch to 500 kilometers. How thick is the liquid outer core of the model? So the first thing we want to do is write out what our scale is. And we were told right here that our scale is 1 inch to 500 kilometers. So now I have that written out here. And again, that is the scale. Now we're going to fill in what we need to solve for. So we were told that the outer core of Earth is 2,300 kilometers thick. So we put the kilometers on the bottom so it matches up to the kilometers in our scale. And then we're solving for what it is in inches. So we have x on top. Then to solve this proportion, we cross multiply and solve for x. So first we would do 500 times x is 500x, and then 2,300 times 1 is 2,300. So I get this equation. To solve for x, I'm going to divide both sides by 500 and get 4.6 is x. So the outer core of Earth is 4.6 inches thick for this scale model. Okay, let's look at another example. A lighthouse is 160 feet tall. A scale model of the lighthouse has a scale of 1 inch to 8 feet. How tall is the model of the lighthouse? So first we're going to write our scale, which is 1 inch to 8 feet, and then fill in the information we're given and what we need to solve. So we're told that it is 160 feet tall in feet, but we want to know what the model is going to be in inches. So again, we cross multiply and get 160 equals 8x. Divide each side by 8 to get x alone, and x equals 20. So the lighthouse is 20 inches tall in the model. What we're going to talk about now is scale factor. And scale factor can be a little bit tricky, which requires an extra step. So scale can be written without units when the units are the same. For example, if we had inches and inches or feet and feet, instead of our previous ones where we've had inches is equal to a certain amount of feet. The scale without units is called a scale factor. And the only way you can have it without units is if the units are the same. So let's look at an example. A scale drawing of a spider is 5 centimeters long. The actual spider is 10 millimeters long. What is the scale of the drawing? So notice the first question says scale only, not scale factor. So it can have units and it can have different units. So all we're doing is writing the scale, which is the drawing length and the actual length. So the drawing length is 5 centimeters The actual length is 10 millimeters long. We can reduce that to get 1 centimeter to 2 millimeters. So that is our scale. Part B asks, what is the scale factor of the drawing? So remember, scale factor means that there are no units. So since we're finding the scale factor of the drawing, we need to figure out this proportion using the same units. And once it's the same units, when we write it, we don't even have to include the units. And that's the whole point of the scale factor. So our scale from the previous slide was 1 centimeter equals 2 millimeters. So we want to make a proportion where we have millimeters on the top and centimeters on the bottom, so that millimeters will both cancel out. So let's just think about the relationship between millimeters and centimeters. Well, we know that 10 millimeters is equivalent to 1 centimeter. So there's our next proportion. And of course we can cancel out the millimeters and just multiply straight across. 1 times 10 is 10, and 2 times 1 is 2. And we can reduce 10 over 2 to 5 over 1. And since our units are both centimeters here, we don't have to write them anymore. So our scale factor is 5 to 1. And then you can notice the difference between the scale factor, which just says 5 to 1, or our original scale, which was 1 centimeter to 2 millimeters. Okay, so the difference is there are no units here for the scale factor, and there are units for the scale. Here are your on your own questions.